All right, guys, welcome to another episode of Cuda Education. Today, we are continuing our journey on the depth buffer conversation. Um, this is a very interesting topic, tricky topic. A lot of stuff is going on, and I'm trying my best to make sense of it all. But have no fear, Cuda Education is here. And we're trying to move the needle along and get some more understanding uh, of all that's going on with this application. So for you guys that are new to the channel, um, we are trying to figure out Apple Metal. In this particular case, it's Apple Metal 4, but Apple Metal nonetheless. Apple Metal is the Apple computer graphics platform that is the first cousin of, or second cousin of Mantle, which is the computer graphics platform that was originally created by AMD, funnily enough. But in the beginning, there was Mantle, and then there is Apple Metal, and also tangentially, there is Vulkan. But today, we are tackling Apple Metal in this whole thing. All right, so this is the second video in the depth buffer conversation, and depth buffer basically is the means by which one, figures out based on distance from the camera what objects to draw and what objects not to draw. So if you consider object A, and let's say object A is 1 mile away from the camera for argument's sake, or let's say object A is 2 miles away from the camera. Okay, so object A is 2 miles away. And then you have object B, and object B is, for example, 1 mile away from the camera, and it obscures everything, behind it in that pixel region or in that region. The depth buffer depth test, what it will do is it will not draw object A because object A is 2 miles away and it's behind object B, which is 1 mile away. Okay, so object B is closer to the camera in that region for that pixel, and therefore object B gets rendered, gets drawn, and object A is excluded, is occluded is what they like to say, occluded from the scene, right? Because object A is farther away from the camera than object B. So object B basically blocks, at least for that pixel under consideration, it blocks the it blocks the it blocks the region that object A would display, and therefore object A for that region, that pixel region, is not displayed. So anyway, let's just run the example just to get us give us some context on all that's going on, right? So the idea is that what I want to do, why are you doing this to me? Right, so what I want to do is right, so what I want to do is, well, let's just yeah. So what I want to do is dive deeper into this conversation. So for example, we have this plant here, okay? So this plant, let's say behind this plant, so if we go further behind the plant, we see that we have this lantern over here, okay? So when we go back out, we'll see that this plant is our object B, and this lamp, this light post, is object A. So object A is farther away from the camera than object B. So object B gets rendered and object A doesn't get rendered when we're looking at the camera from here. Okay? That's the way I understand it. I could do it with, for example, the two plants here. So we have one tree here and one tree here. So this, when we're here, this doesn't get rendered and this gets rendered because it's closer to the camera than what's over here. Okay? So this is this is the conversation that the depth buffer is having. Okay? And what it is, when you're comparing distances, you're comparing when you're comparing distances, it's called a depth test. Okay, so we have a depth test of this and this. Okay, so let's say we render this object first. Let's say this wasn't here, and we rendered this tree first, right? And let's say this tree has a depth test of 2, right, for 2 miles. Okay, or let's say this light post had a depth test of 2. Or the tree. We'll just leave with the tree. So the tree has a depth test of 2, and we rendered it because it's the only thing in our scene. Then the algorithm gets to this object and it says, hold on, there's another object that we want to draw, but we have to run it through the depth test. We have to figure out, is this tree closer to the camera than this tree? Now, when we run it through the depth test, we see that it comes up with a value of 1. Okay, so previously, for the original object, we had a value of 2, right? The depth test value was 2. Okay, the depth buffer value was 2. Here, the value is 1. So because now we investigate this object, we run it through the depth test, and we understand that it is a value of 1, which means that it is closer to the camera. We therefore decide, okay, we are going to render this object. We're going to render this object, and we're going to occlude, or we're going to remove this object from the perspective of what I'm looking at right here. So for these pixels, instead of rendering the tree behind it, I render the tree in front of it, right? Because it is closer to the camera. So we render this tree and we remove this tree from the scene. Okay? Now, notice that we talked about updating the value, right? So we're updating the value. When we find an object that's closer to the camera, because basically we're considering stuff, we're drawing stuff, we're rendering to the screen, that object has, for that pixel, for that region, it has a depth value, right? And we're always comparing to see, for this object, for this thing that we're adding to our scene, is the depth value closer to the camera than what we had before? If it's closer to the camera, then we render that object, that pixel, or the pixel of the object, however you want to slice it. But we render it and we exclude everything behind it. Now, if, let's say, the algorithm goes through its thing, the application goes through its thing, and it's considering another object, but the other object is literally right behind this object right here. It's like literally, it's in between here and here, but it's literally right behind here. Upon consideration of the depth test is going to reject that object. It's not going to render the object because it fails the depth test. So let's say you had an object that wants to be rendered, but it is at a distance of 1.5 away from the camera. If it's a distance of 1.5 away from the camera, it's going to reject it, okay? Because it is too far away from the camera, okay? Conversely, if we had another object that is 0.3, let's say 0.3 miles, away from the camera, we would accept that because it passes the depth test. Remember, this value now is 1. Okay, this value has a value of 1. The object behind it had a value of, let's say, 2. So this has a value of 1. And we're always comparing everything for these set of pixels for the value of 1. So if we had another object that was right in front of this tree, you know, we would, and it had a value of 0.3, it would take precedence, it would override the value for that pixel now. So instead of the value for the pixel being 1, the value for the pixel will be 0.3, for example. And then the new depth test will be, hey, do you have a value closer to the camera than 0.3 for every pixel in this region that you are trying to render something for? Okay? And if you have something closer, we'll render it and we'll reject, what's behind it, what's not visible. But if it's not closer, so let's say it's 0.4 or 0.5, we're going to reject it because we have an object or something that is 0.3, that's closer to the camera, and it will literally block visibility. Okay? All right. So you understand now this idea of the depth test and the depth value. I have to maybe clean up the language that I use, but essentially, we write a depth, the depth right. We write a value based on the distance to the camera, and every object that's closer to the camera than what we've already rendered, that what we've already seen is it takes priority, takes precedent, and then we remove things behind it. Okay. So one other thing I actually want to discuss with this is that so let's say we have a situation where an object is partially blocked, right? So we have this tree here and this tree here. Remember, this object, every pixel, there's like a million pixel or a lot of pixels. I don't know. You guys are 4K and 8K and 1080p and all kind of craziness. I don't have time to keep up with all that stuff. But basically, these tests are done pixel by pixel. So this pixel takes this object, whereas this pixel takes that object, right? These things are rendered pixel by pixel. So even with a partially blocked object, it's not like an object by object basis. It's a pixel by pixel basis. So for this pixel, we're going to render this because that's the closest thing to the camera. For this pixel, we're going to render this because that's the closest thing to the camera. For this pixel, we're going to render the awning because that's the closest thing to the camera. And actually, this object that we have here, it doesn't have any kind of anything to influence this region right here. So obviously, it doesn't render, right? So we have the awning, we have the tree, and we have the other tree over here. But these tests are done pixel by pixel basis, okay? So what we want to do now, remember, depth test, right? Everything is a depth. So this is a depth test here. 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 This is a depth test. Everything is a depth test, okay? This is a depth test here, which means that we can't see the piece of the brick that's behind this because this takes precedent over what's behind it, okay? So everything is a depth test. So right now we have depth enabled as yes, depth right enabled, which means that when we have an object that's closer, we update the value. So for here, we're updating the value to this for this particular pixel, right? We're updating the value because we have something that is closer to the camera than everything else in the scene. Here, we update the value for this pixel, we update it to this guy because this is the closest thing compared to every other thing in the scene, okay? One other thing is that fog, the volumetric scattering, the fog doesn't apply to this. Okay, so fog is a whole different conversation, and we're not gonna worry yourself about fog. So all this stuff we're dealing with objects in the scene. We're dealing with the floor. Um, the fog doesn't apply to this conversation. Okay, so again, we are updating values for the depth test based on the distance to the camera. Okay, so this depth test value is going to be different from this depth test value, right? Because this is closer to the camera than this, but there's nothing else. There's nothing else for this region of pixels. There's nothing else closer to the camera than this. So this is what we see. All right. So what happens when we turn? What happens when we turn? When we turn the depth right off? Okay. What happens when we turn the depth right off? Okay. So what does that mean? The algorithm is running. The application is running. We have objects that we have up for consideration, but we're not updating the depth test value. Okay? If we don't update the depth test value, then basically everything gets rejected. Okay? So let's say when we start the application, when we press run, right? We have a depth test value of, let's say 1. Okay, we have a depth test value, no, let's say 0.1. So we have a depth test value of 0.1. Okay, which is really close to the camera. Okay, like literally right in front of it, like literally as far as your nose is to your eye. Okay, like right in front of the camera. Okay, if we start off with that initial value for the depth test, and then we start to render a whole scene like what we have here, what happens to all those objects? All those objects, which is not literally right in front of your eyes, right to the distance to your nose, it's not right in front of you. What literally happens with that, with all those objects and all those items in our scene? What happens to them? What happens is that let's see what happens. So now we're not updating the depth test values at all, right? We have a default value which is really close to the camera, and then nothing. Okay? So what happens here? What are we seeing here? All the objects are rejected. Okay? All the objects are rejected, right? All the objects are rejected, even when I remove the fog. All the objects are rejected. Don't worry about all this stuff right here. This is like some other stuff that I don't fully understand yet, but basically for what we were considering, all the objects are rejected, right? All the objects that we had in our scene are rejected. And that makes sense because we are no longer updating our depth test values, right? So, we basically we set it at the initial value, based on the clear. There's like a clear value, like when you clear the frame or clear the scene or whatever, and basically, we never update the value. We never update the value at all. So basically all of our objects in our scene fails. Now the lights and the thing, also the sky, don't worry about the sky for now. But basically all the objects are rejected, right? And that is because all the objects fail. in our depth test. Right now, I haven't fully dived into how all of this works. I've been experimenting with the clear value and all that, but it doesn't do exactly what I expect it to do, which means that I don't fully understand the story behind it. Okay, when we update the values, we're putting in objects. We have objects for consideration, and we're putting in values. We basically get back our objects. Now there could be an argument that the clear value, because actually the clear value, yeah, it could be that the clear value is really, anyway, I don't even want to get into that. But essentially what happens when we don't update the depth right, when we don't update the depth right values, is that we reject everything in our scene. And we don't have anything because we reject everything. And then we just have the fog and like the lights and stuff, but the actual objects and stuff we don't have. Okay, now let's go a little step further. So one of the things that, and maybe this is the reason why we have our maybe this is the reason why we have our maybe this is the reason why the windows still show in the why the window still shows in the scene. Okay, all right, so we have here a transparent window. Okay, we have here a transparent window, and behind the window we have a wall. Okay, so we have a transparent window and we have a wall. Transparent window and a wall. Okay, this is a very important discussion as it relates to this topic. Okay, so apparently with opaque, I mean not opaque, with transparent objects, what happens is that you disable the depth right on when you're rendering the glass. Okay, so the transparent window, the glass, you disable the depth right for that particular object, because you still want to render things behind the glass. Okay, so I'll repeat. When you're dealing with transparent objects, for example, a window, a glass, a transparent glass, okay? You want to render the glass, okay? You want to render the object, but you also want to be able to see things behind the window, okay? You want to be able to see things behind the window. So you're not gonna update the depth test to just where the window is, because remember, if you update the depth test just to where the window is, where the transparent object is, you are going to reject everything behind the window, all objects and stuff behind the window. So you don't want to do that. So when you're dealing with transparent objects, you render the object, the window, the transparent window, the transparent glass. You render the glass, but you don't update the depth right. You don't update the depth value, because you still want to be able to render objects behind it. Okay, because again, the glass is transparent, so you want to be able to render the things behind it, and that's what that's sort of another way to look at all this depth test stuff. Okay, so I say that all to say that when we go to when we go to our application, right, I'll just basically do this. Okay, so when we go to our application here and we look at, like that particular object or situation, we're going to see that we're going to disable the depth right for that particular object, because we are we have a transparent edge object. So, okay, give me an example of two objects that are drawn on top of one another, even though one should be removed based on the depth test. Example, draw a semi-transparent glass window first, then draw a solid wall behind it. If the glass is using a depth state with depth right enabled equal no, it won't write its depth. When the wall is drawn afterwards, it can still pass the depth test and show up on top, quote unquote, on top of the glass, even though it's actually behind it. That's why transparent objects are usually drawn last, sorted by back to front. Okay? So this is following along with our same, situation that we saw. Draw a semi-transparent glass window first, then draw a solid wall behind it. If the glass is using a depth state with depth right enabled equals no, so we're not enabling depth right on the glass, it won't write its depth. When the wall is drawn afterward, it can still pass the depth test and show up on top of the glass, even though it's actually behind it. That's why transparent objects are usually drawn last, sorted front to things. So we draw the glass, what have you, but we don't restrict, like for each pixel in this region right here, we don't restrict it to whatever the depth test is of the glass, because we still want to draw the chair. We still want to draw the glass, the wall. We still want to draw the painting. We still want to draw the lamps. We still want to draw the plates and the table and everything behind it. So we can't update the depth test value to the glass, because if we do that, we're going to reject everything inside of, behind the glass, right? So that's exactly what this is trying to, that's exactly what this is trying to say. Okay, so if the glass did write its depth, so I continue with the conversation. So if the glass did write its depth, then the wall would not be drawn at all, because it would fail the depth test based on the new value set by the glass. Is that correct? Yes. If the glass writes depth and is drawn first, the wall pixels behind it would fail the depth test and be rejected. So you'd lose the wall entirely. That's why transparent objects typically keep depth testing on, but disable depth right, and are drawn after opaque geometry. Right? So you guys understand now, we get a little better understanding of what's going on with this guy right here. Okay? We understand that you could manipulate the depth test and the depth right, because I was like, okay, what's the difference between the depth test and the depth right, and what are you writing, and what is this right stuff, and like, you could write and you could not write, and da 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 da, and I'm like, what is all this? But you kind of get an understanding now when you're dealing with transparent glass, right? Right, so like when you ask, tell me what it means when you set depth test to no. So when you set this guy to no, so let's just start from the beginning here. It means the depth buffer will not be updated by this depth stencil state. Depth testing can still occur, which was kind of confusing to me. So depth testings can still occur if enabled elsewhere, but the fragment's depth won't be written. So subsequent draws won't be occluded by this draw. So basically, subsequent draws won't be removed from the scene by this draw. This is typically used for transparent objects, skyboxes, or debug overlays where you want depth testing without affecting the depth buffer. Right. Right. So when it uses the word occluded, it means basically, removed from the scene. Depth testing can still occur, but the fragment's depth won't be written, so subsequent draws won't be occluded by this draw, right? each pixel, remember when we talk about fragments, we talk about color and all that stuff. So like each pixel is like a fragment, and it has a behavior and a color and stuff and all of that, right? But basically, if for the glass, even if let's say for whatever reason, this material that we have for the glass was, it's truly transparent, right? For whatever it's worth. If we enable the depth right on the glass, we wouldn't see anything behind it, because we updated for that pixel, we updated the value of the distance from the camera to this right here, and everything else behind it would be rejected, right? I don't have the know-how to really like enforce the right on only on this glass right here, but you can imagine that if we enforce the depth right on this glass, that basically we wouldn't see anything inside of the window, right? And that's pretty much what I wanted to cover today in part 2 of the depth buffer conversation. All right, so it gets a lot more involved, than this, because you could do it on like more granular basis and all of that. But just as a final thing to just do good housekeeping, let us investigate where exactly this setting is. So this is the depth state, depth right enabled equals yes setting, and it is inside of the, where are you, load metal with view function. Okay, so let's see. Okay, load metal with view function. Initializes metal structures and states for rendering. Okay, so we are in modern renderer application, renderer, AAPL renderer, right? AAPL renderer. And then we're in the load metal with view function. Initializes metal structures and states for rendering. All right. We always want to like keep an eye out on where exactly we are. I don't want to just give you lines of code and like, say here is this line of code and this is what it does. We're actually trying to learn metal, okay? And as you can see, guys, the directory structure for metal is no joke. Is a lot of files, and stuff going on. That's a blessing and a curse. The blessing is that you have absolute control over everything that happens. The curse is that you have a lot of files and folders to deal with. Okay, but we are in renderer, AAPL renderer. So if anyone asks where Cuda education is at, we're in renderer right now, and we're in AAPL renderer file, not the header file, the main metal file. Okay, and that's all I have for today, guys. The clear value thing. So just so we go full circle, we'll just we'll run this again with no depth right at all, and basically what happens is that the clear value the clear value basically rejects all these objects. Now the value of the clear value is a little bit confusing to me, I'll admit, because it's not what I expect. But basically what happens is that the default initial value rejects all the objects, and then therefore nothing renders except the window. Well, maybe, okay, so maybe let us continue our conversation. So if we're trotting through the fog, guys, we're trotting through the fog. So if nothing renders on the window, then we only see other transparent objects. So you see, all the other objects have a value associated with them, and all the other objects have a depth right associated with them, and therefore it's sort of like the object gives away its secret, and because it gives away its secret, we don't because it gave away its secret about what value it is and what distance it is from the camera, and it gave away its secret because it's trying to write a depth value, the application says, okay, you are of that value, I'm removing you, right? But notice that the windows and all of the transparent objects inside of the scene, including these glasses, notice that the transparent objects inside of the scene also get displayed because it's not trying to write a depth value. It doesn't have a depth value. So we do have our transparent glass, but it doesn't. It removed everything inside of it, except for the other glasses, which it's not telling its secret. So there you have it, guys. There you have it. That's why I keep telling you, Cuda Education, you gotta like, subscribe, comment, tell your friends, anyone that's artistically inclined. You understand? This is where it's at. There's nowhere on the internet that you're gonna find this stuff. Nowhere. No one's gonna teach you this stuff on YouTube, right? They'll sell you a game though, but they're not gonna show you how to do stuff, right? So there you have it. You have a transparent object, and nothing is being rendered inside of the window. All right. So you guys know what to do. You got to subscribe, like, share, tell your friends, get a community around. For you MacBook Neo guys, come on, you MacBook Neo guys, you could run this stuff. You have the latest hardware. You can run Metal 4. Okay. So you MacBook Neo guys have no excuse, okay? There is, you can't say you didn't know and no one wanted to teach you, all right? So this is the, this is what it's all about. Right, so everything else basically, I guess the light doesn't have a value, it doesn't do a depth right or whatever, I don't know. The light and the fog don't apply really, and yeah. So there you have it, guys. Thank you for watching. Have a great day. Let me before you guys go, let me put this back to what it was before, because I don't like to have this where where it doesn't Okay, so we're back to where we were before, okay? Now we know about our windows, and right, and now we get all our glasses. So this is the window, and we see all our glasses and stuff. Notice the glasses were the only things that were transparent. Okay, so there you have it, guys. Computer graphics to the world, right? All right, have a great day, guys. Thank you for watching. Support the channel, all that good stuff.